heating, ventilation, and air conditioning. How can you make that exciting? That's the real question.
The project started with a discussion about, hey, we've got an issue in second-year architecture. The air is just absolutely ridiculous, and it's impossible to work, and the students are either too hot or too cold.
First, when the air conditioner wasn't on because it was winter, so we had to get that turned on before we could even start anything. Then when we got that turned on, it wasn't really working. And then they sort of fixed it, and we didn't have the hurricane force winds blowing anymore.
Once the air conditioner was fixed, we did find out through discussion with the students that the airflow and the cool was not consistent throughout the space. So people directly under the air conditioning unit or the diffuser were really hot. People 10 feet out were frigid and couldn't keep anything on their desk. And then people all the way against the wall were burning up because they had no air getting to them. And then they had, the sun coming in from the natural light.
The question was how could we slow that down, diffuse the air, allow people that needed air conditioning to actually get the air conditioning, and then stop blowing things away right in the front. The opportunity was that we could actually try and redesign the diffusers, right? As they were, they had these pieces of cardboard all over them, and it was embarrassing as a design school to have these strange things attached to the ductwork to try and keep the wind off of people.
We had to create a way to measure the air. Some of it was visually with string, some of it was with the anemometer.
The anemometer was not as sensitive as we were hoping, and so anything under 0.2 meters per second wouldn't register. We made a really great structure of hanging 4-foot lengths of yarn, and instead of using the anemometer, we ended up having a visual record. If the strings were moving, then there was airflow there.
Where we put up string, you could begin to see how it really worked, and I think that's really helpful for designers particularly.
We began by drawing things, by modeling things. Instead of trying to make a duct like everybody does, a big long duct and you push the air as fast as you can to the end of it, what they were doing is they were creating this kind of spout or a shelf that the air would just kind of carry along. And that's pretty crazy, because that's not how you usually do HVAC. So thinking about it as a shelf, thinking about it as this flow, was a much more poetic way to think about HVAC, and a much more poetic way to think about air in general. Pretty quickly, we came up with, I think, 6 different designs. And what was interesting is then we brought those designs into the computer. We started to think about the geometries of them, think about how they were constructed, thinking about the different methods by which they would start to diffuse air. We were super lucky to have a mechanical engineering student be available to us who was willing to model these things and see how they would work in the fluid dynamics modeling system.
My part in this project involved taking all of the solid models and created 3D dynamic flow trajectories so that we would be able to visualize how the air would flow through all the different designs.
We chose one of them, and we decided we were going to try and build this thing. We were agnostic about form to a certain extent. We were up for whatever they were going to design. When they came up with something that was 18 feet in diameter, we were like, all right, this is completely insane as a diffuser, but it is absolutely something we should try and do.
When we went into fabrication, it was kind of all hands on deck.
We had a huge participation level from our students. We had 15 or 16 students on this project.
We had a group of students that would typically come on Monday night who had their own dynamic, and then we'd have another group of students on Tuesday that would come and had a totally different dynamic. And it was a really cool experience to be able to see how those students interacted with us and how those students interacted with each other.
So we worked with PVC, Mylar, and plastic core.
We built it in phases. We built the outer ring first, which is a PVC ring.
We had to measure the PVC, we had to cut the PVC, we had to clean the PVC.
It is one thing to design something on a computer. The second it moves over into the material world, and you run into all kinds of problems of materiality.
We connected the vertical pieces of PVC to the longer pieces with the T-joint.
This contact cement, that it's pretty much contact cement. It's almost immediate. And so, you had to get this T node connector onto a piece of PVC at like 7/8 of an inch in, and you had to do that pretty much with one swing of a hammer.
I mean, it had to be instant. So it was glue, put it on, hit it hard, you know, go to the next one, hoping that they would be balanced, you know.
I actually wasn't here for the first stage of building, which was the frame. So when I came into it, everyone was just like, look how big these frames are. This thing's gonna be ginormous, which was a little intimidating. The larger the idea, the larger the concern of, is this actually gonna work? Are we actually gonna be able to do this?
Getting it into the building and between spaces because of the radius became difficult. It became a question of how to squeeze it through things without breaking it.
Leanne went and figured out a certain pattern for all of these vertical mylar pieces, these diffusing pieces, and printed them all out on 3 50-feet rolls of paper.
As it turns out, you can only make a PDF that's 15 feet long, but we ended up with these 15-foot long sheets of paper with these things printed on it, and they were printed at full scale. So that allowed us to have a pattern to work from, and it created a certain level of precision that was really helpful.
We had to first cut them out and then put them onto the mylar and then cut them out as close as we could. And mylar, if you're not familiar, is slippery, and we're working with paper that has very little weight on a slippery surface, especially a surface that you can't really stand on. It became quite a challenge, especially since it's 4 feet wide and you're not allowed to stand on it and you're trying to cut, and it actually turned out really well and turned out to be a very fun night. So the next day they finished off really quickly and they worked with the plastic core.
Working with a white material is hard. It can get filthy very quickly, and unfortunately the corrugated also dense, so we had to be careful about working with the material.
We had said that we built it in stages, but predominantly the thing went up in one day. Students came in around 4 o'clock. They had already had studio class and their other classes of the day. We started with, okay, here's the Mylar, and here are the 3D prints, and here's the plastic core, and oh boy, this huge 18-foot diameter circle. And then we started to raise it up getting into position. Certain things are, kind of sagging, certain things are higher, certain things are lower. We've got students standing on safe equipment with, this thing on their head because their arms have been holding up for a while and their arms are getting tired. And once we got the grid up, then all of a sudden it would start to pull the Mylar. I was actually, at that time, I was in the digital fabrication lab, laser cutting the acrylic. Once we had that, then the students were able to finish off the Mylar that attaches to that, which we used command strips to attach to the actual diffuser on the wall. Once we got that, then it was a matter of we need to bring the big, huge sheet of plastic core. Plastic core, which is a great material in certain dimensions, but linearly, if it's laid flat, it doesn't really have a whole lot of structure to it. And so we've got something that needs to be suspended, raised off the ceiling. How can we do that? One of the things that we really, truly thought of was, we could 3D print these things.
My part in the project was to do a bunch of 3D modeling and do the 3D printing for the joints that hold up the diffuser.
We had a system where we would have a node and we'd have a little wooden dowel and we'd have this paracord. We didn't realize that, hey, that's great that we have this, but we got to tie from the top and this thing is about 8 feet wide. So how do we get above it and tie? Adam worked it out. He was starting to do tying underneath, and we were happy with the result. It gave color on the bottom. It gave a little bit of breakup of that surface, and so we felt like it was a really good solution. This thing is kind of wanting to bend down, and we're trying to make sure that it doesn't kink, doesn't break, and doesn't fall apart. We came kind of on the fly with a leather punch and punched holes in it, and was working with knots and tying.
The actual design had the things that diverted the air. It had the actual material straight, and we ended up tying that at an angle, so it actually ended up looking a lot cooler than it was supposed to. So.
Eventually, after 8 hours of building, at around midnight, we called it quits, and it was done.
We were there for quite a bit. We kind of had to cram it all in at one night, but honestly, I'm kind of used to it because that's what we do in this program. We just stay here for hours on end working on something, and the next morning we forget we did it and come back and see something cool up on the ceiling. So I think it's worth it.
It all went amazingly smoothly. I mean, hiccups aside, because hiccups are expected, but it went amazingly smoothly, and we got it all put together, and it works and it looks good.
The design actually came out a lot better than we anticipated just because of the way the materials interact together. The design went into my personal studio in school, so regardless of whether or not it functions as ideally as we'd hoped it to, aesthetically it increases the experience of the space tenfold, if not 20-fold. It was just a really awesome experience to get to put it up there and see people's reactions.
One of the great things about ArTech Fusion is it's an opportunity to bring art and technology together. And this was really an opportunity for us to design something super interesting that also had a technological focus. And so making something like HVAC actually an interesting thing and figuring out a way to poetically design for that thing. The elegance of the project, the thoughtfulness of the project really came through, and it really spoke to the strength of the designers, which are our students. Looks pretty good. I think it turned out all right.
Anemometer? Anemometer. And, sorry, I'll stop doing that. Anemometer.
Anemometer. Anemometer. Anemometer.
What is it? Anemometer? It's the wind speed thing. Yeah, I don't know. Anemometer.
Anemometer.
Okay, anemometer.